Welcome to a lesson with Dr. Powell. Let's take a look at a recursive sequence and how we can write this recursive sequence in terms of a matrix. First of all, what we're going to do is we're going to think, okay, so we move from two positions in our sequence, like one position, another position, into the next two. So the process of moving from these two positions in the list to the next two is going to be given by a function. All right, let's suppose we're at x and y right here. How would this function go? Let's see. So we input two positions. How are we going to get out the next two positions? Well, the first guy is going to be just y. And what about the next guy right here? This formula tells us exactly how to do that. All right, so this tells us that the next place, so what goes right here, is actually precisely 3 times the guy right here in this position. That's an, is an plus 1, that's an plus 2. So it's 3 times this guy minus 5 times that guy is equal to that. In other words, it's 3x minus 5y. Now this function is a linear transformation. It's additive and scalable, and we can work with that. We can write a matrix that describes it. If we think of a column interpretation, we're just thinking about what's the destination of E1, what's the destination of E2. Where E1 is just 1, 0, E2 is 0, 1. So where does this go? So x is 1, y is 0. Let's see. Y is 0 and x is 1. So it looks like it's going to be 0, 3. Great. Okay, now what about the next part? 0, 1. Where does that head? So we input a 0 for x and a 1 for y. It looks like we're going to get a 1 and a minus 5. We've just successfully described this recursion in terms of a matrix function, where if we input like an and an plus 1, we would end up getting the next two slots or positions, an plus 1 and an plus 2, just like that. And then from there, we would keep on going. If we want to create a formula for this sequence, if we want to write a formula like a sub n is equal to something, how could we do that? But right now, at the moment, you think about this, we kind of have a formula that we kind of go from right here, a sub n, and we're going over to a sub n plus 1. Okay, and we've kind of moved one position up right there, and this is a first power. So if we're thinking about that, what if we started with a0 right there? So if we had an a0, let's just think about what that would be like. If we had an a0 here and make this an a1, a0 and a1, then that would take us over to here. That would be a1 and a2. All right, so we kind of have this step from a0 to a1. Now, what if we wanted to make this a step to a2? And that would be an a3. We would just have run this function twice over. So that would be a matrix power, so this matrix squared, because matrix multiplication is just composition of functions. Great, so we successfully changed that to a 2. So what if we want to change this now to an n? Then what would we do? Well, we just change that power to n. And there we have a way of getting from this column vector to this an right here. And if you want to pick out, let's think about this. So we run this through, we're going to get a column vector. Now, if we want to pick out the first row, we think row interpretation multiplication. We just say 1, 0, and that'll pick out the first row, first entry right there. So essentially, what we're going to do to come up with this formula, we just simply have 1, 0, and then we have our matrix 0, 1, 3, -5 raised to the nth power, and then we multiply by a0, a1, which is simply -2, 1. And what we have just done is we've described this recursive formula as just a formula for an equal to something where we have a matrix power involved. Now, there are ways of working with it past here, but in this video, we're just describing how to write down a formula for a sub n that has a matrix power in it. Thanks for watching.